Hello everyone. Today we are going to create an effect where a character affects blowing particles. These particles can be any mesh or material, as long as they meet the nature of blowing particles. Okay, so here we use a banknote material as an example. Here is its texture, just a banknote, and this is its material. One thing to note is that this time we didn't use mesh renderer, but particle renderer to create this effect. So we need to use two-side sine node in the material to ensure that the material is displayed on two-sided normally. Of course, the output value needs to be clamped to 0 to 1. The default output value is -1 to 1, which will make the texture color on the backside look strange. Okay, now we can connect the output to lerp and use lerp to display different textures on both sides. A outputs the texture of the upper half, and B outputs the texture of the lower half. Here we add the two textures into one texture, so we need to use TextScore to scale and offset the texture. If you use two textures, you don't need these steps, just connect them directly. Connect the base color, emissive color, and opacity, and we will have a material for the banknote. We can use it in Niagara without a mesh, pretty good. Okay, let's create Niagara. First, select the material we just created in the particle renderer and change mode to self and infinite in the lifecycle. Then add spawn rate, set spawn count to 100. Now we can see these particles. Then in the initialize particle, we set lifetime to 12 to 15, so that the particles will exist in the level longer and it will be more convenient to interact with character. Particle color don't need to be set, the default material color is enough. Then we can set mass. These values can be kept as the default, because we will use some force modules in particle update. Different mass will present a more random blowing effect. Sprite size also needs to be adjusted, X is 15, and Y is 7.5. Now we add shape location to set the initial position of these particles, set sphere radius to 500, Z-axis offset to 200. So that these particles are spawned above the floor. Then we need to use the method mentioned in the previous video to let the particles get the random rotation of the mesh. Add initial mesh orientation. It seems to have no effect now, but don't worry, we just need to add a line sprite to mesh orientation in the particle update. Fix issue, and we can see that these particles have random rotation. Then we add gravity force in particle update, keep the default gravity, and add a wind force. Let's fix these issues. Set the speed to 200 on the x-axis. Scale speed is 0.5 to 1. These parameters in turbulence can be modified according to our needs, but I think the default values are enough to simulate the effect of particles blowing, so keep it as default. Then in aerodynamic drag, set its drag to 0.3 to 1. Rotational is 0.1 to 0.3. Lift contribution is 0.7 to 1, and rotation strength is 0.5 to 1.5. These parameter values are not fixed values. We can adjust them according to our needs. Next, we add a collision. Use GPU simulation will be better. And change the collision mode to distance field. Set friction to 2. Friction during a bounce is 0.1. We don't need rest state, so disable it. Okay, now let's see this effect in the level. Yes, we also need to set the direction of the particles on the floor when they collide. Add align particles with collision plane to align the particles only on the x-axis, so that when the particles fall on the floor, they will be in the correct orientation. Yes, that's it. Okay, now we are going to make the effect of the character's movement affecting these particles. Let's add a third-person template character, then get Niagara and character in the level blueprint. In Niagara, we need to add a module to get the character's position and the particle's position. If the distance between them is less than a set value, let these particles be affected by the character's speed. Okay, so we first add a character position, and of course the particle position, then add a float, as distance. We also use a float to control the output value. If we use bool to control it, when the character walks through these particles, they will be affected by the same force, and we hope that this force has a fall-off range. These particles close to the periphery will be affected by a smaller force, so it is better to use float to make it. Okay, let's add distance-based fall-off. The start position is the character's position. The end position is the particle position. This parameter setting for the distance, and the output is connected to normalized fall-off. This is a module. Okay, now add a linear force. We use linear force to simulate the influence of particles when the character moves. Use lerp to control the size of the force. Alpha is the output float in the module. It should be noted that the coordinate space should be changed to world space. Input A is the strength of the force when the particle approaches the character. We add a vector and rename it velocity because it represents the speed of the character. B represents the strength of the force when the particle is at the edge of the range. We can keep the default here. Then we also need to get character's position in Niagara, so add another vector and name it location. Let's set these parameters and distance is 100. Then open the level blueprint and set the user parameters in Niagara. Vector, first set location, the character's position in the level, and V, which is the speed of the character. Now we can get the world location of the character, select the location of the mesh, then the velocity, we get velocity, add a value in the positive direction of the z-axis, because the character has no velocity on the z-axis when moving, and we want the particles to fly up, so add the velocity of the z-axis, such as 500, and then connect the value of the velocity output to V. That's it. Niagara gets the location and velocity of the character. For now, due to the effect of drag, the value of V should not be enough to affect the particles, so there should be no change when the character walks on the particles. We need to set V a little bigger, such as multiply it by 20, so that there should be a large enough value to affect these particles. Yes, it worked. Now we can see that the character will affect the surrounding particles. Let's disable the wind force. It will be very obvious when we look at it this way. The character will affect the surrounding particles when running. We can also set this distance a little bigger, such as 200, so that it will affect the particles in a larger range. Of course, we can also change the material of the particles to petals, leaves, and various materials that require this kind of blowing effect. Okay, that's all for this video. I hope you like it. Bye.